Okay, in this video I'm going to be explaining the relationship on the slice a little bit more after yesterday's class. Um, this is a problem I pulled out of another book. You've got a cylinder tank on its side and it has a radius of 4 feet, length of 10 feet with a spout reaching up to the ground at 10 feet. This is an underground tank full of water. Want to know how much work is required to get all the water out of the tank. Again, I guess water is 62.4 pounds per cubic foot, and I'm looking mostly at the relationship here because that was where everybody was asking questions yesterday. Now, again, I want you to know that we're not solving. I think that's where everybody's getting kind of mixed up. We're not solving for anything right here. What we are doing is trying to find a relationship. It doesn't have to make sense with the problem, but what it has to do, you have to have a relationship in terms of h or y, so you can take the antiderivative. I think that's the best way to explain it. So many times in math we think we got x plus 4 is equal to 6 and we're supposed to solve it, and we're supposed to get some kind of answer like this. Well, that's fine when you're doing algebra. Here we are using a geometric relationship with turning r into terms of h or y. So you can substitute in the y for the r, and that's the best way I can explain it. Each time you have a circular a cylindrical tank on its side and the slice is going to be going up and down like this, it's going to be going from up to like that, then you're going to be using this relationship, which involves the Pythagorean theorem. And in this case, the radius is 4, and the diameter is half, the radius is half the diameter. Now here, you can use R if you want to. I use D because it goes all the way across, so that's why I use D. And the relationship you're looking for, you've got 10 foot of pipe and 4 foot radius, and we're going to make that 14 minus h. So if you put it in the Pythagorean theorem, here's your 14 minus h, here's your 1/2 d, and here's your 4. Then 14 minus h quantity squared plus 1/2 d quantity squared is equal to 4 squared. Paper there. And when you work that out and solve for d, you're basically, I'm just going to draw a squiggle here, you can do the algebra. D is equal to 2 times the square root of 16 minus parentheses 4 minus h squared. And that is your d. Now, of course, radius, you divide that by 2, you divide that by 2, so radius is equal to the square root of 16 minus parentheses 4 minus h quantity squared. And if you were going to continue with this problem, you would set it up with the integral. You multiply by the distance. I think the distance would be 18 minus h, and then you would go from it's full, so it'd be from 0 to 8. So I'm just going to put that on here. Integral from 0 to 8, and I'm just going to put everything in the 62.4 times 2, that'd be 10. I didn't do the other part, so I'm putting it all together. 10 times the square root of 16 minus 4 minus h quantity squared dh times h 18 minus h. And that would be your integral. Most of the time in these problems, they're going to set you, they just want you to set up the integral or the antiderivative. So I'm going to go ahead and pull out the 624, 0 to 8, of 16 minus 4 minus h quantity squared times 18 minus h dh. And if you want to take it one step further, 624, that would be, take 18 out. I'm just going to put brackets there. 18 integral antiderivative 0 to 8 of this 16 minus parentheses 4 minus h quantity squared minus the integral h times the square root of 16 minus 4 minus h quantity squared dh. And one of these, let's see, I think this is where we need to stop, because it goes into, you have to go to the table of antiderivatives to do there, and that's where we ran into a problem with it the other day. Most of your problems are going to ask you to set up the integral. And I hope that helps explain that relationship.